Good day, grade 12 learners. Welcome to today's physical sciences lesson. My name is Bongani Mabuya. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Today's lesson, we are going to focus on electric circuits. As we prepare for our preliminary exams and for our year-end examination, it is important that we deal with electric circuits. Why electric circuits? It is because when we do our diagnostic analysis term by term, it has been found that a lot of learners, they are struggling or they are having challenges with electric circuits. So it is important that we bring a revision to you learners that will have an impact. Because what we want to achieve is that when we look at the electric circuits, they account for 22 marks for your preliminary exam and 22 marks for your final exam. So it is important that we bring back the confidence of saying that when we attempt or when we respond to electric circuit questions, we should have confidence and make sure that we get maximum marks. So what we are going to do today, it is to make sure that we bring electric circuits to the level that can make us to be confident to answer it well and get maximum marks. Because what is it that we want? It is for us to do well in physical sciences, and we must do well as we prepare for preliminary exam and do well for our final exam. So that is the topic of the day. We are going to do electric circuits. Now, the lesson objective, what is it that we are going to deal with today? We are going to compress electric circuits to 3 concepts. Because when we look at the composition of electric circuits, we find that there is a big relationship between these 3 concepts, namely the current, the potential difference, and the resistance. So we are going to compress this lesson to demonstrate the relationship between the current, the potential difference, and the resistance. That is what we are going to do today. It is to make sure that we develop that confidence of looking into electric circuits and saying that this topic is about 3 concepts: the current, the potential difference, and the resistance. So today we are going to learn more about the potential difference, but we must start from the definition. For us to understand this potential difference, we must know how to define the potential difference. And we can define the potential difference in 2 ways. We can define the potential difference as the energy transferred per unit electric charge flowing through it. Or we can define potential difference as the work done per unit charge. Because when you look at the formula for the potential difference, it says V is equals to W over Q. So when we talk about the potential difference, we are talking about the work done per unit charge. Furthermore, we are going to talk about the units for potential difference. We measure potential difference in volts. Why must we emphasize this point? So, we are emphasizing that you must write the correct units, because when you perform your calculation, we need to follow this strategy. The strategy that we are following is called facade, which is FSAUD. What does facade mean? It means that for us to get maximum marks in a calculation, we must write the correct formula, F for formula. And then we must substitute correctly from the formula. And then from there, we are going to get our answer. And that answer must have units. If we are dealing with vectors and scalars, it must also have direction. So when we perform a calculation, it is important that we are cognizant of this mnemonic called facade. So the units for the potential difference, they are volts. So when you are asked to calculate the potential difference in an electric circuit, you must make sure that you write the correct units. And also, another question that might come as well, it could be, what device do we use to measure the potential difference? So the device that we use to measure the potential difference, it is called a voltmeter. So now we have addressed three things here. We have addressed the definition, the units, and the device. Then later, we are going to deal with the grade 12 aspect that started from grade 11, the EMF. Why EMF? It is highly linked to the potential difference because we define it as the maximum. It is not the total. It is important that we write the correct science. It is the maximum energy supplied by the battery per unit charge passing through it. So we are going to deal with the EMF as well. And then we'll look at the difference between the EMF and the potential difference and measure it as the current flows through the circuit. Then we are going to deal with the current. Remember, I said this topic, we must comprise it to three concepts: the potential difference, the current, and the resistance. So what is it that we are going to learn today about the current? It is the definition of the current. What is the current? It is the rate of flow of charge. Number two, we are going to look at the units that we use to measure current. And those units, they are amperes. Number three, we are going to look at the device that we use to measure current. And the device is called an ammeter. So in an electric circuit, when you see an A, then you know that this is where we are measuring the current. When you see V, you will know this is where we are measuring potential difference. Then we'll look at the equation of the current from grade 10 that says current is equals to the charge per unit time. So it is the rate of flow of charge. So we're going to have to use our prior knowledge of grade 10 and collaborate it, integrate it to grade 12 content. Then furthermore, 1 coulomb, we are going to define the charge as the charge transferred in a conductor in 1 second if the current is 1 amperes. Then we're going to indicate the direction of the conventional current. What else are we going to learn about today? Resistance. Remember, we said we've been looking at this elephant. So for us to bite this elephant, we need to make sure that we deal with it bit by bit, bit by bit. And how do we do that? We compress electric circuits to 3 concepts: the current, the potential difference. Now we are going to the concept number 3, which is resistance. We are going to define resistance as the ratio. That's what we are going to define resistance as. It is the ratio of the potential difference across a resistor to the current in the resistor. And also, we know a simpler version of resistance, that it is the tendency of the opposition of current. We are going to look into that as well. Not only that, we'll have to interpret a graph where we look at the relationship between the resistance and the current, the relationship between the current and the potential difference. And also we will be in a position to distinguish between the ohmic conductor and non-ohmic conductor, or ohmic resistor and non-ohmic resistor. Furthermore, the reason why we are doing electric circuits in grade 12 is because we are integrating two concepts from what we have done in grade 10 and grade 11. In grade 12, we are including the EMF. We're also including the internal resistance. So you'll be given a circuit diagram. Composition of it can be a series circuit, or it can be a parallel circuit, or it can be series parallel circuit, or it can be parallel circuit. But in everything, or when we analyze our circuit diagram, it is important to be cognizant of the EMF and the internal resistance. So, when we look at the circuit diagram, you'll be expected to solve problems. You'll be expected to perform calculations. So you'll solve problems using current, voltage, and resistance. And the arrangement of the circuit diagram, it may vary. If you are lucky, you can have a series circuit, you can have a parallel circuit, but usually it's series parallel or it's parallel. But you will be restricted to 4 resistors. So the examiner is aware that whatever that I can assess learners with, I must be limited to 4 resistors. So the circuit diagram that you will get for prelim, which is good news, it will not have more than 4 resistors, excluding internal resistance. Now, we are going to define EMF because it is our grade 12 content. And a definition that we are going to provide of the EMF, it is the definition that comes from the exam guideline of 2021. Because for a learner to do well in physical sciences, the equipments that you can use to make sure that you succeed in passing well physical sciences, there are 2. Number 1, you must use the exam guideline of 2021. Number 2, you must use the data sheet. And then we are going to solve problems using the formula of the EMF, V load plus V internal, or EMF is equals to I R external plus I R internal. And I still repeat, for your prelim and your final exam, you will be restricted to the maximum of 4 resistors. So good news for us. We'll analyze not more than 4 resistors. Now, the prior knowledge from grade 10, in fact, not even from grade 10, from grade 7 in natural sciences, grade 8, grade 9, you had an opportunity to engage with electric circuits. Grade 10, the content started to become highly theoretical, introduction of major calculations. Grade 11, complex calculations, and grade 12, we're going to do more of complex calculations. So electric circuits, it is the content that we are exposed to. We've been doing electric circuits from grade 7 up until grade 12. Now, if you look at grade 7, grade 8, grade 9, the much focus was on the establishment or the connection of a circuit diagram. And you had an opportunity to use the components, look at their symbols, to establish a series circuit, to establish a parallel circuit. To an extent, you have to investigate the intensity of light when you connect the light bulb in series and when you connect the light bulbs in parallel. So this is what we've been doing in grade 8, grade 9, and then grade 10. We had an introduction of calculations, where you have to calculate the current or the charge, you have to calculate for the potential difference, you have to calculate also for EMF. Introduction of EMF, it starts from grade 10. Because when you look at the exam guideline of grade 10, it specifies that there should be an introduction of the term EMF from grade 10. Then grade 11, you did EMF and internal resistance. Grade 12, we are revising. We are making sure that now we are polishing our skill in such a manner that we can get maximum marks. So these were the components that you were using in grade 6, 7, 8, 9. A cell is represented in this manner. A battery, it is the connection of many cells. Switch, if the switch is open, we know there is no current that will flow to the circuit. If the switch is closed, the current will flow throughout the circuit. And then a straight line represents a conductor. And then we're having what you call a light bulb. Sometimes you don't use a light bulb, we use a resistor. So why am I indicating or having a particular interest to light bulb and resistor? It is because a light bulb and a resistor, they serve a same function. A light bulb is a resistor. A resistor is a resistor. So when you see a light bulb, you must make sure that you remember this. We are seeing a resistor. When you see a resistor, it is a resistor. Voltmeter, when you see V, you know we are reading the voltage. Ammeter, when you see A, you know we are reading current. Then, grade 8 and 9, including grade 10, because you had to do an experiment in grade 10 of electric circuits, there was more emphasis on the connection of the ammeter and the connection of the potential difference device called voltmeter. So we said that an ammeter should be connected in series. A voltmeter is connected in parallel. So this is a simple representation of a circuit diagram. You can see the components. We're having a battery, we're having a light bulb, a resistor, we're also having a voltmeter that is connected parallel to the resistor, also having the ammeter that is connected along the resistor in series. Now, before we can start with the lesson of the day, because we need to know that we want to provide a revision program that will enhance confidence in you. We want you learners to get maximum marks in electric circuits. It is possible. Electric circuits comprises of 3 concepts. In everything that we do, we must ask ourselves a question. What is happening to current? What is happening to potential difference? And what is happening to resistance? So before we can move any further with our lesson and have a discussion, I want us to do this little baseline assessment. Please respond to these 2 questions, and then in 3 minutes, we will tackle the feedback. Thank you. Now, I want us to look at our responses. So this is our baseline assessment. It assesses our actual development. What is it that we know now about the electric circuits? And how far should we go with this revision? The first question, what is the current strength? If 5 coulomb, we're talking about the charge, moves past a fixed point in 2 seconds, we're talking about the time. So we're having the charge, we're having the time. The question is asking you, what is the current strength? Then it means you must borrow from the grade 10 formula sheet, where it defines current as the rate of flow of charge, which is current is equals to charge divided by time. So this would be our response. You must write the formula as original as it is. Current is equals to charge over change in time. You get a mark for that, provided that you have substituted. So it is important that you write the correct formula, and what do? You substitute. For you to be credited the 1 mark of the formula, it requires you to substitute. Write the formula as original as it is, and then what do? You substitute. That's the next step. So here, current is equal to charge over change in time, 1 mark for that. Then we are looking for the current. We are given the charge, which is 5 coulomb, divided by the time in seconds, which is 2 seconds. Then you get a mark for the substitution. Then what will be your answer? 2,5. And then there are units. Because we are calculating the current, we must make sure that we put the correct units, which is 2,5 amperes. So we are bringing an emphasis to you learners that no matter how excited we can be, let us make sure that we put the correct units. The second question, calculate the number of electrons that moves past a fixed point if the current, we're given the value of the current is 10 amperes, it flows for 10 seconds. So the first thing that we do, we can rearrange this formula. I is equals to Q over change in time. We are given the current, which is 5 amperes. And then we don't have the charge, but we know the time is 10 seconds. Then what do? You transpose divided by 10. You'll have 5 times 10, meaning that your charge will be 50 coulombs. So it's 1 mark for the original formula, 1 mark for the substitution, and 1 mark for the answer. So we are motivating you to write the formula as original as it is. Now, once you are having the charge, you have not yet answered the question. It said, calculate the number of electrons. So you can see it's a bit of a high order question. Once you are having the charge, then you can say number of electrons is equals to charge over quantization of charge. And this calculation, we know it from electrostatics. Now you can see that we can integrate, we can steal some concepts from other topics and use them in electric circuits. Because physical sciences is one. So the topic that we do this week, it links to the topic that we'll do next week. Then our charge is 50 divided by quantization of charge is always constant. You need to familiarize yourself with the formula sheet. The data sheet, it should be your friend. I did say our equipment to win or to get maximum marks, there are two. It is the exam guideline of 2021 and also the formula sheet, which is the data sheet. The quantization charge is equals to 1,6 times 10 to the power negative 19. So when you divide both of them, you will get 3,12 times 10 to the power 20 electrons. Before we get to the lesson, here is another quick multiple choice question. Now, I'm interested in your answer. I want us to provide feedback to this question, a multiple choice question. Learners think that multiple choice is easy. But if you can look at the multiple choice and the way in which it has been arranged, particularly for paper 1 physics, It is the summary from question 1 to question 10 of what we'll be doing in question 2, Newton's laws. Question 3, vertical projectile motion. Question 4, momentum. Question 5, work, energy and power. Question 6, Doppler effect. Question 7, electrostatics. Question 8, electric circuits. Question 9, electrodynamics. Question 10, photoelectric effect. So, a multiple choice is not a guess game. It is the actual content. So, we need to develop a skill to try to get correct answers on the multiple choice. Because we don't just guess, because maybe the name of your grandmother is Dorothy, therefore the answer will be D. No. We don't guess. We don't guess, my learners. We must make sure that we read the statement, we understand the statement, that this question, it deals with electric circuits. Then from there, which formula can I apply, or which law can I use to interpret this scenario? And once you are having that, you must know a multiple choice is structured in such a manner that two answers, they are obvious distractors. You must eliminate them. And then you'll be left with two options where one is correct and the other one is more correct. So you must always choose the one that is more correct. The second diagram shows a 4 ohm resistor and an 8 ohm resistor connected to a 6 volt battery. What is the potential difference across the 4 ohm resistor? So, in this instance, they wanted to test your knowledge of the connection of the series circuit and the parallel circuit. So, we know that in series, the current is the same, but the potential difference is divided. In parallel, the current is divided, but the potential difference is the same. So you must look at this connection. You look into it and say, are these resistors connected in series? If your answer is no, it means they are connected in parallel. So in parallel, we are saying that the current is divided, the potential difference is the same. So if we're having 6 volts here, and then the potential difference across the 4 ohm resistor is going to be the same, 6 volts, and the potential difference across the 8 ohm resistor will be the same, 6 volts. Now you can look at the options. Which option has 6 volts? And your answer will be D. So that is the correct answer. It's D. Let's look at the next question. I'm giving you 1 minute and then we provide feedback. Now, let's look at this question. It's a multiple choice question, and we are saying that we must not be triggered by this question and just choose any letter. It is important that we read the statement, we link the statement to the content that we have done, and then from there we look at what does this question want. Must I perform a calculation, or must I use a law or a principle for me to get the answer? 4 options that you will get in a multiple choice question. 2 options, they are obvious distractors. They are wrong. 2 options, they are correct, but 1 is more correct. It might be the issue of misconception that makes the other one wrong, or not rounding off correctly, or missing one item as we perform a calculation. 2 5 ohm resistors are connected as shown in the diagram. What is the total resistance in this combination? It wants us to do a calculation. So before we can perform the calculation, we must look at the connection of these resistors. How are they connected? These resistors, they are connected in parallel. And how many are they? We're having two resistors that are connected in parallel. If we are having two resistors only that are connected in parallel, then you are allowed to use this formula. Rp is equals to R1, R2 divided by R1 plus R2. So Rp is equals to the product of the resistor divided by the sum of resistors. Then it's going to be 5 times 5 all over 5 plus 5. And our Rp, I think, is going to be 2.5 ohms. Now you are having the answer. Then you go to your options. What is the total resistance of this combination? A, less than 5 ohms. B, 5 ohms. We know B is wrong. C, more than 5 ohms and less than 10 ohms. D, 10 ohms. We know 10 ohms is wrong. So these are the obvious distractors. Then we are left with the two options, A and C. You look at your answer. Our answer is 2.5 ohms. So 2.5 ohms will dwell more on option A, that our total resistance in this combination would be less than 5. You can also do this one in 2 minutes. Let's look at your response. The diagram shows a 10 ohm and a 20 ohm resistor. What will be the reading on the voltmeter? So we know that the potential difference in series is divided. So because here we're having 20 ohm, meaning that we're going to need more work done in moving a charge from one point to another. So our answer, it cannot be 12, because this potential difference, it will be divided to 10 ohm and 20 ohm. So 12 is out. And then our answer, it cannot be 4, it cannot be 6, because we need more work to remove the charge from one point to another. So the correct answer will be C. So that is how we deal with the multiple choice question. Then, more than anything, I did say that for us to be successful in ensuring that we meet our desired results, it is important that wherever we are, we must have our equipment at hand. And for us to pass electric circuits, we must make sure that we are familiar with the exam guideline of 2021. That is our holy book in physical sciences. It is the exam guideline of 2021. And the examiner is structuring the preliminary exam using the exam guideline. The examiner cannot go beyond what the exam guideline dictates. So for us to be safe, it is important that we familiarize ourselves with the exam guideline. Because even if we want to contest a definition or a concept, our referee would be the exam guideline. So it is important that we make sure that in everything that we do, we must refer to the exam guideline. What does the exam guideline says about this aspect? So we're looking at electric circuits. It says that this must be read in conjunction with the KEPS document, page 88, page 89, and page 121. The first thing that the exam guideline says, we must deal with the Ohm's law. and you must be in a position to state Ohm's law in words. So if the examiner asks you to define Ohm's law, it is a fair question. Because where does it come from? It comes from the exam guideline. So the first bullet of the exam guideline, we must state Ohm's law in words. And how do you state it? According to the exam guideline of 2021, it says that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. That's what the exam guideline is saying. The potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. So for us to obey Ohm's law, everything must happen under constant temperature. The potential difference will be directly proportional to the current, but where? At constant temperature. So let's make sure that we write the definition the way it appears from the exam guideline, at constant temperature. Then it says you'll determine the relationship of current, potential difference, and resistance. Remember, we said we are comprising this topic into three concepts. It is made up of current, potential difference, and resistance. So when we talk about the Ohm's law, actually the Ohm's law, it is the one that explains the relationship between the current, the potential difference, and the resistance. So we should be in a position to demonstrate that relationship in a simple circuit and also with graphs. State the difference between ohmic conductors and non-ohmic conductors and give example of each. Ohmic resistor and non-ohmic resistor. And you'll be given a circuit diagram. I did say 4 things or 4 possible scenarios can come from the circuit diagram. 1, it can be series circuit, I doubt though. 2, it can be parallel circuit, yes. 3, it can be series parallel circuit. 4, it can be parallel circuit. So you will be required to solve problems using the formula of Ohm's law. R is equals to V over I for series and parallel circuit. But the circuit diagram that the examiner must provide, it must not exceed 4 resistors. So the exam guideline is putting the law that we can expect not more than 4 resistors. Then you must be in a position to define power as the rate at which work is done. You know, we defined power from work, energy, and power. Power is coming back again in electric circuits. Power, it is the rate at which work is done. And I'll emphasize this. Let's make sure that we write definitions the way they appear from the exam guideline. It is important, learners, it is important that we write the definition not according to our understanding, not according to the material that we are using at school, at home, not according to YouTube, but according to the exam guideline of 2021. That power is the rate at which work is done, because the memo will speak to the exam guideline of 2021. So that's another definition that we can expect from the question paper, power in question 8. So we've spoken about 2. The examiner can say state Ohm's law, and now the examiner can say define power. Then we can borrow from work, energy, and power. It is the rate at which work is done. But also there are 3 formulas in grade 10, 11, and 12 that speaks to power. We can calculate power as VI, We can calculate power as I squared R or power as V squared over R. So we can calculate power in 3 ways depending on what we are given on the circuit diagram. And then the units for power, they are watts. So as you calculate power, don't forget to put the W. Then we'll look at the cost of electricity. Yeah, it's a question of application, and you can expect such a question. You did it in grade 10, you did it in grade 11. Then we are saying that more than anything in grade 12, we are focusing on internal resistance and the EMF. So you'll have to solve problems of current, voltage, and resistance. But you need to know again, we will be limited to maximum of 4 resistors. Another definition that the examiner can provide is the one of the EMF. It is the one of the EMF. So it means the examiner now is having 3 definitions at hand to use for prelim and to use for final. So the examiner has the right to ask you to define the EMF. And learners, you need to understand that we're not saying understand the definition. A definition is a recall information. You must know how to define, and that's all. So the exam guideline of 2021, it is saying EMF, it is the maximum. It does not say it is the total. It is the maximum energy provided by a battery per unit charge passing through it. So that is the EMF. So if the watch at home is no longer functional and you go to the store to buy a new battery to replace the old one, you'll find that the battery is written 1,5 volts. That 1,5 volts is the EMF. It is the maximum energy that battery can supply. And you'll be required to solve problems using the formula E is equals to V load plus V internal with internal resistance. This small r, it speaks to the internal resistance. And what is the internal resistance? Internal resistance, it is the resistance found within a battery. Or we can say EMF is equals to I plus I. So that's another method that we can use. So let's summarize what we've been saying. And we've been saying one thing over and over again. This topic is about 3 siblings: the current, the potential difference, and the resistance. So from grade 10, you defined current as the rate of flow of charge. That's how you define current. It is the rate of flow of charge. So when electrons are moving per unit time, we are saying that we are having what? The current. So the current, it is the flow of electrons per unit time. Now, what is important about this current is for us to know 3 things. What is current? It is the rate of flow of charge. We've defined it as well from our lesson objective to say that at the end of this lesson, a learner should be comfortable to have a thorough discussion about current, about potential difference, and about resistance. So what is current? It is the rate of flow of charge. Now, once we know that, we need to know now the units for the current. So when we perform a calculation for the current, we must make sure that we put the correct units, which is A. So whenever you are required to calculate for current, put the correct units. Facade. Let's look at the device that we use to measure current. We call it an ammeter. We call it an ammeter. So when you see the symbol A in the circuit diagram, you must know this is where we are reading the current. Let's come to potential difference. What is potential difference? It is the energy transferred per unit charge, or it is the work done in moving a charge from one point to another. So that is the potential difference. It is the work done. A potential difference, it is the energy that we use to move a charge. Now, what is important about the potential difference? It is for us to know the units that we use to measure potential difference. And those units, they are volts. So when you are required to calculate for terminal potential difference of V external, V load, V internal, EMF, let's make sure that we write the correct units. And what will be our correct units? For potential difference, our units, they are volts. Now let's look at the device that we use to measure potential difference. And the name of the device is called voltmeter. And then we see it by the symbol of V. So when you see V in the circuit diagram, then you will know this is where we read the voltage. Then resistance, we did say that it is the ratio of the potential difference in a resistor. So it is important for us to look into it with more simple English. Resistance, it is the opposition of current. The higher the resistance, the lower the current. So resistance, it is the opposition of the current. Now, what are the units for the resistance? So if you are required to calculate R external, for instance, or R internal, those are the resistors, equivalent resistance. You must know that you must write the correct units. We measure resistors in ohms, and the symbol for ohms is like this. So the symbol for the resistor is ohms. And then the device that adjusts resistance, we call it a rheostat. So a device that adjusts resistance, we call it a rheostat. So this topic is about these three concepts: the current, the potential difference, and the resistance. Now I want to go one step deeper. Let me go deep. Let's look at the relationship. How do they impact each other? The current, the potential difference, and the resistance. And for us to understand their relationship, we must look at the law that best describes these three concepts. And that law is called Ohm's law. It is called Ohm's law. What does Ohm's law says? It says that the potential difference across a conductor, is directly proportional to the current in the conductor at constant temperature. So that is why we're having this formula: R is equals to V over I. So this formula, it tells you that if we increase the resistance, what will happen to the current? The current will decrease, because the higher the resistance, the lower the current. The higher the current, the lower the resistance. So another mnemonic is that I always enjoy linking physical sciences to real life experience. So when I was young, I think around 12, 13 years, I used to have a friend called Ntokozo. And they used to have a big, beautiful garden at Ntokozo's home. So every day would go and help out with watering of plants and the grass. So Ntokozo would say, no, go and take the hose pipe from the garage, and I'll go there, take the hose pipe, and then connect the hose pipe to the tap, and then roll it over to Ntokozo. Ntokozo will stand on the other side where there is grass and flowers. And then I'll quickly run back to the tap and wait for Ntokozo to say, open the tap. Then I will open the tap, and then the water will flow inside the hose pipe so that Ntokozo can start to do what? To water the garden. And Ntokozo used to have a sibling. Whenever Ntokozo would scream and say, open the tap, the sibling will come out and go and hold the hose pipe and try to bend it over. So I realized that actually what was happening there, it was science. It was electric circuits, to be precise. Why? Because the tap served as the potential difference. It provided the energy to move water from one point to another. When water was flowing inside the hose pipe, that was our current. Because what is current? It is the rate of flow of water. It is the rate of flow of charge. Now, Ntokozo's sibling was acting as a what? A resistor. Because the more the sibling tries to bend the hose pipe, what is happening? Water becomes restricted. So the more the sibling will bend the hose pipe, we know that what will happen? Ntokozo will receive water less on the other side. So it is important for us to link our everyday experience to science. So the tap was the potential difference. The flow of water was the current. And Ntokozo's sibling was acting as a resistor. I'm not saying Ntokozo's sibling was a resistor. He was acting as a resistor. So the higher the resistance, the lower the current. The lower the current, the higher the resistance. Now, the exam guideline then it says we must be in a position to distinguish between an ohmic conductor and a non-ohmic conductor, an ohmic resistor and a non-ohmic resistor. So when we talk about an ohmic conductor or an ohmic resistor, it is the resistor that obeys Ohm's law. If we talk about a non-ohmic conductor or non-ohmic resistor, it is the resistor that does not obey Ohm's law. So when you look at this graph, this is the graph of Ohm's law. The current is directly proportional to the potential difference. That's what Ohm's law says. The potential difference is directly proportional to the current. It says that. The potential difference is directly proportional to the current. So as we increase the current, also the potential difference increases because they are directly proportional at constant what? Temperature. Then a non-ohmic, now this one you can see as the start does not increase, and eventually it increases. Why? Because it does not obey Ohm's law. A typical example, an ohmic resistor, it can be a diode. A diode that is a small red or green lights that we find inside the plasma or inside an electronic device. That is a diode. So a diode is an ohmic resistor because it obeys Ohm's law. It does not change. Now, the light bulb is a non-ohmic resistor. Why light bulb is a non-ohmic resistor? It is because the more the current passes through the light bulb, that is why when you switch it on at home, you leave it for 20 minutes or 30 minutes, you switch it off. When you touch the light bulb, you'll feel the warmth, or the light bulb will be hot. So it means that hotness, that change in temperature, it does not obey Ohm's law, because we are saying for us to obey Ohm's law, the potential difference should be directly proportional to the current, but at constant temperature. We can't have a difference in temperature. So that is why a light bulb is a non-ohmic resistor.